Hello guys, welcome to my channel. In this lesson, I will show you how to find nth roots and how to find principal nth roots. Okay, all right, let's go ahead and get started. Let's take one example, start from one example. All right, let's look at number one. Look at the square root of 16. Okay, so nth roots just represent square roots, third roots, fourth roots, fifth roots, and so on. Okay. All right, so here we have square roots. Square roots can also be written like that, okay, like this. All right, because it's just two, so we are allowed to just write square roots like this for short. All right, so now here, if I'm looking for maybe the square root of 16, we know that -4 times -4 is 16. And we also know that 4 times 4 is 16. So that's why if we found the square root of 16, we'll say it will be plus and minus 4. So this will be the square roots of 16. But then if you're talking about a principal square root, the principal square root must have the same sign as 16, which is called the radicand. Okay? So the number and the radical sign is called radicand. It's because the radicand is positive, so you want a positive answer. So that's why we'll throw out the negative sign and just keep positive 4. So that will be the what? The principal square root. Okay. All right, so but if you're looking at the nth roots, there will be positive and -4. Well, the principal has to keep the same sign as the radicand. So let's go and do another one. We're looking for the third root of 8 over 27. So in this case here, we're going to consider the numerator and the denominator. Okay, so for 8, we know that 8 is 2 times 2 times 2. So which means the third root of 8 will be 2. And then we'll also look for the third root of 27. So for 27, we have 3 times 3 times 3. So that's why we just pick one copy of that, and that will be 3. So again, that means that the third root will be 2 over 3. Okay, so in this case, now we just have 2 over 3, especially because of the root. The root here is odd. So the principal root would just be 2 over 3. Again, you can see that they have the same sign. This is positive, and the radicand is also positive. So let's go to another example. So let's look at this example here that says find the principal and truth or the principal third root of -8 over 27. This is negative. All right, so because we have the fraction is negative or the radicand is negative, so what we can do here is to look at the factors of -8 and also look at the factors of 27. Okay, the negative factors of -8 will be -2 times -2 times -2. So if we multiply all these three numbers together, all with the negative sign, it will go back to -8. So that means if we're looking for the principal third root of 8 over 27, you get -2 divided by, we know 27 is just going to factor into 3 times 3 times 3. So we just pick one of them, so 3. So in this case, -2 over 3 will be the principal third root. Okay, let's do more examples. All right, let's take this. For example, we have the fourth root of -16. All right, let's see if this is possible. Now, to find fourth root, we need 4 numbers of the same copy. So we know that 16 is 2 times 2 times 2 times 2. But because we have a negative sign, we try to throw in negative sign for all 4 and see what we get. Negative, negative, negative. All right, so we have 4 negatives. But then the problem is if you have, because this is even, 1, 2, 3, 4, the copies are even. If we multiply this number, it will just collapse down to positive 16. Yes, so that means there's no way you can write the negative factors of 16 to give -16. So it's not possible. So because we cannot do this and this is not possible, we say we do not have, you say no real fourth roots. So no real fourth root. So because this is not possible to decompose -16 into -2 multiplied to each other in 4 places to give 16 back. So this is not working. All right. And then we do not have +16. So we cannot just find fourth roots, and we can't find the uh, principal nth root as well, or the fourth root as well. So let's do another example. Let's take, for example, we're doing the fourth root of 81. To find the fourth root of 81, I just know that 81 is 9 times 9, and 9 it means 3 times 3, and 9 also means 3 times 3. So which means 81 will be 3 times 3 times 3 times 3, and that will be 3. So that means the 3 would work. What about if I do -3 times -3 for negative factors, and then -3? So if I multiply all these copies together, I will get +81 as well. So which means if I'm asked to look for the fourth roots of 81, it'll be plus and minus 3. Yes, but they are positive and negative. Each would give 81. But then I want the principal root, the principal fourth root. So if it's the principal fourth root, then the radicand is positive. So that means I get to keep just a +3. That would be the principal fourth root for that one. So say, for example, I have to find um, another one, which is the fourth root of -81. So in this case, I'm looking at, okay, just factors of 81. We just figured out that it will be 3 times 3 times 3 times 3. All right, take a moment to observe to see if you're going to be able to find the fourth roots, the principal fourth roots or not. All right, welcome back. All right, let's see what we're getting. Here, since we have negative radicand, so we expect to distribute the negative sign for everything. But when we multiply all these copies together, it will collapse to 81. So there's no way we can get -81 from these factors. So this is not working. So we'll say no real fourth roots. So sometimes too, you may not have real square roots, you may not have real third roots, and so on and so forth. So, for example, if we consider looking for the square root of -9, we know 9 is 3 times 3, right? And then if we distribute the negative signs for everybody, all the numbers, we do not get -9. We get +9. So this is not going to work. So you say no real square roots. So you cannot do that. It's not possible because -3 times -3 is going to give +9, and there's no way you can do that. So if you know that 3 times -3 will be -9, but then you want to make sure that you have negative on both factors, right? So that you can say it is -3. Otherwise, if you cannot do that, that means you do not have real square roots in this case. And this is how we will do this. And I'll see you in the next lesson.